Okay, hello everyone, and welcome to Module 3. So in this module, and in this first discussion I'm going to have with you, we're going to talk a little bit about climate change and global warming and sort of the natural events with this. As you all know, this is part of the big debate. Do human beings really play a role in this whole discussion about global warming and climate change? Some of you may have some very strong opinions on this. Some of you may be on the fence. Well, I'm not quite sure. Okay, so we're going to take a look at sort of the naturally occurring events that we know out there that is, part of this whole discussion in this topic. Okay, so let me go to the lecture outline here for you guys. And so I'll be just moving right on down the line. I've got some images for you as well with this. Okay, so one thing to keep in mind in this discussion is the reliability of the data on this. And this is something that I covered, of course, in the last discussion of Module 2. In this, we always try to look at this in a geologic time frame. Now, geologic time frame is a little bit hard for human beings to sort of relate to. You and I can relate to 50 years, 100 years, maybe 200 years, but it's hard for us to relate to something 500,000 years ago or 2 million years ago. That's just not really in our realm. The other debate with this is that, how reliable is this data? You and I might look at data that's maybe, 10, 20, 50, 100 years old and say, okay, I find that to be more reliable than data that's maybe 500,000 years old. Great, I understand where you're coming from. But of course, the more data that we can look at, the better it is for us to kind of formulate our opinions and our theories with this, okay? So the first thing I want to discuss, I have right here on the handout, is that sort of the human influence and role in this whole debate about global warming and climate change. So the question I'm asking, is global warming part of a natural process? And there's really two approaches to this that I'd like for you to be aware of. If human beings play no role with this, if global warming and climate change is just a natural process and human beings largely play little to no role in this, then do we really need to have this discussion anymore? Because if it's inevitable and there's nothing we can do about it, then the first thing I would say to you, we don't need to have this discussion anymore. Okay. The second thing that I would say to you is that if that is the case, then we need to quit talking about fossil fuels. We need to quit talking about human activity. And what we need to do is spend our time preparing for what may be forthcoming. A rise in sea levels, drier conditions in places that are already dry, wetter conditions in places that are already wet, okay? We need to start building the arcs. We may have to pick up and move from places like Nevada, all right? If we go into what some scientists believe, we're going to start to enter these mega droughts. Instead of having droughts for only maybe 4 or 5 years, we're talking 30, 40, 50, 60 years. I can tell you, and I think we can all agree, Nevada couldn't handle a 50-year drought. Could you imagine, if we went through a 40, 50, 60-year period where we were getting below normal precipitation? I don't think we could survive here, okay? So we do know that nature does play a role in this discussion, but the real debate, of course, as you know, is the role of human beings. So I kind of want to start off with this, asking sort of this more rhetorical question. All right, where we go with this. Okay, so there is the study in climatology, it's called paleoclimatology. And when we use the prefix paleo with this, that means sort of historical climates, going back thousands, if not millions of years. And again, this is where some people sort of maybe have a little bit of a hard time getting their heads around, going back this far with this, okay? So how do we study sort of natural processes with this? Well, I can tell you one thing, that over the past 500,000 years or so, we have actually experienced more of a cooling trend, globally speaking. There's going to be one assignment I'm going to have you guys do that you're going to be looking at climate data, not going back 500,000 years ago so much, but you're going to be surprised with how much cooling has actually taken place, okay, according to the research. But nonetheless, we know that over the past 500,000 years or so, there's actually been sort of a general cooling trend. Now, what I mean by this, it doesn't mean that, we didn't have some warming for, a 40 or 50 or 60 year period over that 500,000 years. That's just over that whole time frame with this, okay? Now, the other thing, over the last 10,000 years, and this is where our discussion really needs to kind of come into play with this, is that we went through an ice age, okay? About 2 million years ago, give or take, it was called the Pleistocene. And at that period of time, about 30% of the Earth's surface was covered in ice. Today, it's about less than 7%, okay? So we've sort of pulled out of that ice age. But I have to tell you, in that 500,000 year period, it was predominantly cooler. It's only been within the last 10,000 years, give or take, where we have really seen that really rise in global temperatures, okay? So this has been just a very, very short period of time. And so what happens here is that now we are in what is called a geologic period, what is called the Holocene. That's Holocene. We were in the Pleistocene, and that is the Ice Age, okay? And so what has happened here is that in that warming period, we have gone from about 30% of the Earth's surface covered in ice down to about 7%, okay? So now we start to see the entering of this warm phase where the 500,000 years prior to that, we were more in a cooling phase. Okay, so how do we know about this? Well, we know that something that I've talked about in the past, and I just want to bring these images up again just to humor me here, if you would. All right, with this. This is an image, of course, that I showed you before. We went into places like Antarctica and we cored ice. Okay, and this, of course, is called a proxy. And so we've already had this discussion. We're looking for those air bubbles, and we've seen the rise of CO2 by about 30% since the Industrial Revolution. Okay, so that sort of is one indicator that we've seen some warming with this. Okay, the second thing, and I've not showed you this image yet, there is also what is called ocean coring. And what will happen, if you recall, I mentioned too, the average depth of the oceans, and just take this, simply as an average, it's only about 12,000 feet deep. Okay, so obviously their ocean's more shallow. Then we get towards the Marianas Trench, which is over 30,000 feet deep. But we're able to take these cores and we're able to core down into the ocean floor. And we're able to extract some of the sediment. All right. And this, of course, is going to tell us something a little bit about the climate, what was taking place over long periods of time. Okay, so we know that we already have some of this, all right, taking place. But I do want to point out to you that the warming has only been more recently over more recent geologic time. We've actually been in the cooling phase. Just to let you know, if you actually look at the 20th century, there was a period from about, say, 1940s to the 1970s where we were actually in a cooling phase as well. So it's about a 30-year period where we saw a little bit of dip in the temperatures, but it's been since then that they just continue to go up and up and up over the last, say, 50 years, give or take. Okay, so proxies play a very important role with this. So here's a few deductions I want to point to you that come from, researchers with this. So here are some of the things that we know. This is a general consensus. It is the belief amongst many atmospheric scientists that about every 100,000 years or so, and again, take these numbers just sort of as a reference, don't look at them as gospel, that about over every 100,000 years, you and I should anticipate some sort of shift in climates, okay? And that is more of a natural event, whether it's a warming trend, whether it's a cooling trend, whatever the case may be. And there's reasons for this that we'll discuss here in a minute, okay? So you and I should anticipate this taking place. The argument is that this is more of a natural process, okay? All right. The second thing also that we've actually seen over the last, say, 125,000 years, generally speaking, we've seen a lot less ice and temperatures were warmer. But we had this small period of time here over the last 20 to 30 years where we actually saw significant cooling and we saw a significant amount of glaciation, okay? So I've got this 125,000 years, and over the bulk of this, we've seen less ice, more warming, but we have this little smidge of about 20 to 30,000 years here where we saw a very dip in this cooling and we saw an ice age. We came out of this the last 10,000 years and we saw this warming. Now, again, the point of this, guys, is that, look, you can't say that humans played a big role in this, okay? You might make the argument and say humans played no role in this. Got it, all right? The other thing that I just want to point out to you is that what scientists are trying to tell you is that, look, there is naturally occurring warming and cooling taking place. There is naturally climate change. That is a natural process. So the discussion with this is, though, of course, is that, and I tried to introduce this to you in the last module or the first module as well, is that recently, since the last, say, 200-300 years or so, that trend just keeps going up, 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 and up, where typically it should be coming down, going up, coming down, going up. It's not coming back down. So the question scientists have for this, of course, and anybody else is, well, what's different? What is different between what we've seen in the past, where we see these periods of cooling and warming and sort of this up and down roller coaster effect, is that the argument is, and you'll make up your own mind, is that this involves human beings. This involves fossil fuels, okay? The increase of greenhouse gases, okay? But right now, we're just talking about naturally occurring. This is what I kind of want to get back to with this. Okay, so what also takes place with this? Well, there are a number of things that I want to point out to you that are called natural sort of parameters. And here are the three key terms, okay? And I'm going to go to an image here in 1 second. They have it up there. There is a lot of discussion about how the relationship between the Earth and the sun changes over geologic time. And there is a strong belief that there are changes in this relationship. All right, so just to refresh your memory, the sun sort of orbits, or the Earth, excuse me, orbits around the sun. So we're migrating around the sun over the course of the year. You all know that there are times a year where we're tilted towards the sun. There are times when we're tilted away from the sun in the northern hemisphere. So let me go to an image here that might help you out with this. And this is part of what the belief is with this. So we'll go through eccentricity, obliquity, and what is called precession, okay? And hopefully this is pretty simple, straightforward. But let me go back to my images here, and I'll bring this guy up. Okay, so let me go to that. Okay, so bear with me here. I would just like to get to, okay, there we go. Let me move this out of the way. It's always dodging bullets here with this thing. Okay, so ladies and gentlemen, I'm going to make this as simple as straightforward for you with this. So why do some atmospheric scientists believe that this Earth-Sun relationship plays a role in our climate change discussion? Well, let's go ahead and let's start off with eccentricity, okay? All of this simply means in simple English is that as the Earth migrates around the sun, the pattern or the shape of that orbiting, all right, actually changes over geologic time. So if you take a look at this image here, guys, with this, is that you'll notice this is what's called low eccentricity. And what that means is that we'll see we're almost making this perfect circle around the sun. So everything is kind of evened out here with this. When we have high eccentricity, you'll notice the relationship or the shape or the pattern of that orbiting actually changes, okay? And this is part of what is called an eccentricity cycle. Well, look at it. This isn't rocket science here. If that pattern does change, if the shape of the orbit does take place, Well, then obviously the amount of solar energy that we receive or that we receive from the sun is going to change. Well, if that changes, then obviously climates are going to change. All right. So there is part of this argument, all right, that eccentricity does take place. That eccentricity cycle, as you see on the overhead here, averages about every 100 to about 110,000 years. They have about 111,000 or 110,000 years here, okay? But it tends to be somewhere in between with this. This is one argument that sort of leads sort of science to believe that, yes, Mother Nature does play a role in this as well. Forget about the human aspect. The second thing, and this is what is called obliquity, or sort of the change of the Earth on its axis. Now, if you ever pick up a globe, you'll notice that a globe is not sitting at a 99-degree angle. It kind of sits at about a 66.5-degree angle, okay? It sort of sits on its side a little bit. And so what happens here is that relationship over geologic time, in this case, you'll notice here about every 40 to 41,000 years, is that tends to be sort of this change in the tilt on the axis. Now, let me point out to you, the Earth sits at about a 66.5-degree angle, okay? You can kind of see that tilt there, all right, on the image. Well, that means that what takes place is that the sunlight that we receive is very much focused in what is called the Tropic of Cancer in the Northern Hemisphere and the Tropic of Capricorn in the Southern Hemisphere. Well, the Tropic of Cancer sits at 23.5 degrees north latitude. The Tropic of Capricorn sits at 23.5 degrees south. It's between these two parallels of latitude that the Earth is receiving vertical sunlight, meaning that the sun at some point in time is at a 90-degree angle. Well, Northern Nevada, Carson City doesn't sit within this. So at no given time is the sun directly over us at a 90-degree angle because we're out of those two parallels of latitude. But you'll notice here is that if I'm at 23.5 degrees, at a 23.5-degree angle here at the Tropic of Capricorn, if I take 66.5 plus 23.5, that's 90 degrees. Okay, so I'm 23.5 degrees off of 90 degrees, and that's putting me at that 66.5 degrees. Hopefully that makes sense. Hopefully I didn't botch that for you guys. Okay, so what you'll notice, it is believed that maybe every 40 to 41,000 years, the tilt of the axis changes. And you'll notice here that it's anywhere from about 22.5 to 24.5 degrees. Now you might say, well, look, that's 1 degree different. All right, 22.5, 24.5, that's only 1 degree different one way or another from what you and I know today. But I have to tell you, it's kind of like the greenhouse gases that I said to you that, hey, less than 1% of the atmosphere is made up of these greenhouse gases, but look at all the hubbub it's created. Well, the same thing happens even at a greater extent if that tilt of that Earth's axis changes at all. That is phenomenal, okay, in terms of what we would actually see from this. So again, it takes very little to sort of mess the whole thing up. So again, this is not a human-induced process. This is a natural process that takes place. Okay. Last but not least, and this is what is sometimes referred to as precession, okay, or the wobbling of the Earth on its axis. Now, this one's a little bit harder for people to sort of digest with this, and I really don't have a good analogy with this. But all of you know that if you got in your car and your car's out of alignment, the steering wheel might shake when you hit 65 or 70 miles per hour. Okay, so you sort of get this vibration or you get this wobbling. Well, your car's out of alignment. As silly as this might sound, there is some theory that at times there's sort of this wobbling of the Earth on its actual axis. All right, meaning that, of course, it does it, it sort of wobbles. It's not this perfect rotation, if you will. And this is what is called precession. So it's just simply the Earth becoming somewhat out of alignment. And you'll notice here on the diagram here, this precession cycle is more frequently than, say, the obliquity or the eccentricity. And there's a lot of discussion with respect to how true this actually is. But I just want you guys to know it is being discussed, whether you believe in it or not. Lights just went out, but anyway, hopefully you can still see everything. Nonetheless, it is still something that is discussed with this, okay? And I'd like for you to at least be aware of it. Okay, to wrap this up, there are two very important notions here with this. And let me go back just so that you guys have that. Okay, so here we go. Let me get out of the way here. Okay, so let me go to this here. Forget about that first part that I had on there. I want to skip over that and come back to that later. Okay. There are really three important notions that I'd like for you guys to be aware of. There is a scientific consensus with this, of course, that Mother Nature does take place, and it is beyond any kind of human control. We know that, all right? There's evidence that we've gone through these periods of time of warming and cooling, all right? The most recent, of course, the Pleistocene, the Ice Age. We need to accept that fact that Mother Nature does play a role in this whole discussion. The second thing that always takes place, and it's something that I tried to illustrate to you guys when I went over those few websites with you guys, we're always going to come across faulty climate data. That's going to take place in any research project, all right? There is no research project out there that is infallible. But if you can identify this faulty climate data, then you can try to do something about it. And typically what happens is that if there is data that really seems to be out of the ordinary, it seems to be very skewed, typically what will happen, guys, is that there will be more research done on it. They may test the methodology that data was collected. They may go back and test that site, okay? And again, those of you getting into the sciences, this is your future, okay? You're going to be testing things and retesting things and saying that, wow, the results I'm getting are clearly not in line with what we've seen in the past. Okay, we're going to test this and we're going to retest it. We know this for a fact, okay? And the third thing, of course, that we try to do with this is we try to look at past climates. We try to look at paleoclimates. We try to look at the trends, and what we do is we forecast future climates, okay? So remember, weather and climate is nothing more than trends and patterns, all right? When we forecast something, that doesn't mean it's always going to come true. You guys know that, okay? A weather forecast is put out for the next, say, 5, 7, 10 days. That doesn't mean it's going to actually happen. There's variables that can come in and sort of derail it. But we use the past to try to project the future, okay? And the question has got to be, is that what has been taking place the last 200 to 300 years that is sort of messing with that pattern? And that's, of course, where some people would come in and say, that's the human element of this, okay? My intent here was just to let you know, here are some of the things that are talked about naturally occurring events that play a role in this, okay? So anyway, all subjective, all open to discussion, all open to debate, but just something I want you to see as you continue to work through the class and your textbook, okay? Once again, have a nice day. I'll check back with you in discussions later on. Okay, until then, if you have any questions, let me know. Take care.